Number 26 says that we want to find the integral on which the function is positive. Okay, well, to know when something is positive, what we're trying to do is we're trying to figure out where it hits the x-axis. Okay, all right, and if I find those two locations, if there are two, there might only be one or zero. All right, then I can actually figure out, and I know that this guy points up. Okay, so I can figure out where this guy's going to be positive, okay, and where he dips underneath the x-axis, so that that's where he would be negative, all right? Now, I don't need a graphing calculator to figure this out. What I can do is I can figure out where the zeros are, because I can set this equation equal to 0, and I can find out exactly where it hits the x-axis. If you use a graphing calculator and you needed to find these two, that might be kind of hard to do without using other functions in the calculator. So this is actually probably going to be a faster way. I want to find factors of negative 30 that add up to negative 1, okay? Because what I'm doing here is I'm setting this equal to 0, okay? I'm going to set that guy equal to 0 to figure out where he hits the x-axis. All right, and that's going to be a negative 6 and a positive 5. So x minus 6, x plus 5 equals 0. So therefore x equals 6 and negative 5. So it looks like right here is negative 5, and that's 6. Now, the reason why I know that it's pointing up, again, is because the A is positive. If the A was negative, then that means that these guys would be pointing down, okay? And then my positive would be in the middle. So, where is this guy positive? He's from negative infinity all the way to negative 5, but we don't include the negative 5 because he's actually 0, okay? We want to know where he's positive, not positive and 0. Okay, so we got a U, and then he's gonna go negative, and then at 6, he'll go back positive again, or just above 6, he'll go positive, and then go all the way to infinity. Okay. All right, same thing here. All right, so again, we're gonna set it equal to 0 in our head, and we got 28 that adds up to 11. That's 7 and 4. So we got x plus 7, x plus 4 equals 0. Okay. That tells us that it hits the x-axis at negative 7 and negative 4, so it would look something like this. Okay, we know that he points up, so that's positive, and that's positive, because it's got to dip down here, but we don't care about this part. Okay, it can't go any other way, because if it was like this, then the A would have to be negative, okay, and he's not negative. So we're using a lot of skills here that kind of build on top of themselves. And so our answer here is going to be from negative infinity to negative 7, U, then negative 4 to positive infinity. So it is only from negative 7 to positive 4, negative 4, that he actually dips, okay, below 0. All right. Okay, let's squeeze another one, 3-minute mark. All right, 28. This is a good one. This is actually goes to the inequalities that we were working on. This one, though, is a little bit easier because this guy is actually in vertex form. Okay, so if he's in vertex form, now he's also factored. So what this means is that he only hits. You can look at it like this. There's actually two different ways you can look at it. Okay. All right, both of those are the same thing. But this means then that my answer is just x equals negative 6. That's when it equals 0. Okay. So there's two ways to look at this. Okay. One way is treat this like vertex form. This guy moved to the left 6 units. Okay? Now you have his graph. Now you can see what part is greater than 0. Or look at it like this. In factored form, I only have one answer. I hit the x-axis once at negative 6. He's right there. And I know that he points up. So both ways are going to give you the same result. Okay? Now with this then, I know that the only place that is not greater than 0 is actually at negative 6 itself. Okay? At negative 6 itself is when he is 0, and you are not allowed to be 0. So your answer can look a couple of different ways. You can actually go negative infinity to negative 6, and then a u. Okay, if this makes sense to you, cool. That's totally fine. I know it looks a little redundant, but what you're saying is you're not equaling negative 6 in either of them. Okay? Or, what I think is better is when you write it like this. It's all x such that x does not equal negative 6. Okay? That means you're saying everything else is fair game except negative 6. So this is a little bit more succinct, a little bit more, I don't know, classier. Number 29. Okay, flip this over here. 29 says a prairie dog has an equation that models the burrow if it passes through that point. So, I don't know if I signed 29, but this is actually quadratic regression. Okay, so we're going to skip that one. I don't think I signed it, but I could be wrong. Maybe at the 6-minute mark. Okay, so now we got complex numbers, and we'll just go ahead and make that a separate